M1 Dynamics example 11. It would be worth pausing this example and having a go yourself first if you've already had a look at example 10 because it's very similar. We've got a box of mass 2 kilograms which is being pushed up a rough plane. So imagine this is our box, 2 kilograms. As I read the question, I always label everything as I go along. So 2 kilograms, that's 2g. It's being pushed up this rough plane by a horizontal force of magnitude 25. Horizontal force. So it's not parallel to the plane, it's acting horizontally. We know that we'll have a normal reaction, which always acts at right angles to the plane. And we know we've got friction. Now, because the object is moving up the plane, the friction will resist that motion. So friction will be down the plane, and because we are moving, we must be in the maximum value. So F equals mu r tells us that mu is 0.3, so it's 0.3 r. So we must be at our maximum value of friction. Very similar to the last example, we know that the angle of the plane is 10. So that means that this angle here to the vertical would also be 10. And if you remember angles like this from school, they're called corresponding angles. So if it's 10 down here at the bottom to the horizontal, it would also be 10 here to the horizontal. So if we resolve, first of all, perpendicular to the plane, we know there's no motion vertically, so forces up will equal for forces down. So up we have R, and that will be equal to both components of these two forces. So let's have a look. The 2g, that will be 2g cos 10 to get to the vertical, 2g cos 10. And we also have a component of this 25 acting downwards. And that will be 25, and because we're turning away from the 10, it will be 25 sine 10. So if we work that out, that gives us the value of r. Now, if we now go along the plane, or parallel to the plane, we know that pulling it up will be a component of this 25, 25 cos 10. Resisting the motion will be friction, which is mu r. And also resisting motion will be a component of the weight, and that will be 2g sine 10. So that's the resultant force up the plane, but we know it's moving in this direction, so we're going to be doing F equals ma. So F is the resultant force, 25 cos 10 is up the plane, 0.3 r and 2g sine 10 are acting down the plane, and that's equal to m, which is 2, multiplied by a. Okay, so what we can do now is 25 cos 10 minus 0.3 r. Now we know r from the first line from here. 25 sine 10 minus 2g sine 10 equals 2a. So that's a lot to type into your calculator, but if you type it in really, really carefully, you should get that 2a is equal to 14 and a bit. And so if you then divide by 2 and round off to two significant figures, because it's our final answer, the acceleration works out to be 7.1 meters per second squared up the plane.